All right, so this is section 7.8, which is factoring polynomials completely, which basically just means you're going to factor multiple times. Before I forget to tell you guys this, I want to tell you that sometimes you'll come across polynomials that are not factorable. There is one in your homework that you're going to come across, number 13. So don't get too hung up on that one. It is not factorable. I won't ever give you this on a quiz or a test, but just know that it is possible that some of them are not factorable. So 7.8, we're going to start by 7.8 is really factor by grouping, which we've already done. So we're just going to review that before we move on to the second part of the lesson. So factor by grouping, we're going to group the first two terms together and group the second two terms together, and we're going to pull the GCF out of both groups. So we're going to pull a y out of this first group, and we're left with y plus x. And then my GCF in the second group is 2. So we're going to pull a 2 out, and we're left with a y plus x. So the GCF now is y plus x, so we're going to pull that out, and we're left with y plus 2. Okay. And remember, when you pull the GCF out and you write what's left, remember they're being multiplied together, so don't add in a plus sign here. We don't want a plus sign there. All right, again, group the first two, group the second two, and pull out your GCF. So my GCF in the first group is x squared, so we're left with x plus 3. The GCF in my second group is 1, so we have x plus 3. And then my GCF is x plus 3, so we're going to pull that out, and we're left with x squared plus 1. All right, again, group your first two terms together, group your second two terms together. Now, what you guys might realize is that your third term is negative. Anytime your third term and your third term only is negative, you're going to have to pull out a negative GCF. Okay, so let's look at the first group first. My GCF is 2x squared, so we're left with x plus 4. Again, anytime your third term only, well, whenever your third term is negative, you need to pull out a negative GCF. So my GCF here is negative 3. So when you pull out a negative GCF, I want you guys to write divided by that negative number here so that you don't forget to pull out a negative number. So negative 3x divided by negative 3 is positive 1x. And negative 12 divided by negative 3 is positive 4. Now we know that we got the right GCF because these match. X plus 4, x plus 4. So we're going to pull out that GCF, and we're left with 2x squared minus 3. Okay. If they didn't match, then you want to go back and check your work, and that probably means that you forgot to pull out the negative GCF, or that you forgot to actually pull out the negative. So for example, one mistake a lot of students make is they do negative 12 divided by negative 3, and they'll forget and they'll write minus 4. So you want to make sure you actually do negative 12 divided by negative 3, and we get positive 4. Okay. All right, group the first two together, group the second two together, and you'll notice that the third term is a negative 5x, which means we're going to have to pull out a negative GCF from that group. So we get my GCF in the first group is x squared, so we're left with x plus 2. And then again, my third term is a negative 5, which means I have to pull out a negative GCF. My GCF here is negative 5. So let's pull out the negative 5. Make sure you write minus 5. Negative 5x divided by negative 5 is a positive 1x. And then negative 10 divided by negative 5 is a positive 2. Okay, so make sure you actually do negative 10 divided by negative 5 to get positive 2. So then my GCF is x plus 2, so let's pull that out. And we're left with x squared minus 5. All right, and then because you have a sub, let's just do the star one together. So group the first two together, pull out the x squared, which is your GCF, and we're left with x plus 3. The third term's positive here, so my GCF is positive 5, and we're left with x plus 3. Okay, so we pull out our GCF of x plus 3, and we're left with x squared plus 5. Okay, I did go kind of fast, but that's because this is review, and you guys already know how to do factor by grouping. We use factor by grouping when we have 4 terms. So that's when we use factor by grouping. So just to review before we move on, the very first step, no matter what type of factoring problem it is that you always need to look for a GCF. Whether there's 2 terms, 3 terms, or 4 terms, you always need to check for a GCF first. I cannot stress that enough. That's always the first step. If you have 2 terms, you could either pull out a GCF, or it might be a difference of 2 perfect squares like we learned yesterday in section 7.7. If you have 3 terms, you're going to factor the trinomial. Normally, we just do guess and check. If you guys like the factor by grouping method, you can use that. But normally, to factor a trinomial, we use guess and check method. And 4 terms is when we use factor by grouping, which you saw is what we just did. So again, first step, you always want to check for a GCF first. So my GCF here is 3x. Notice that it's a number and a variable. So we're left with x squared minus 4. And then you have to check what's left over. You have to check if you can factor that. So we learned yesterday about the difference of 2 perfect squares. And this is a difference of 2 perfect squares. Remember, difference means subtraction, and then x times x is x squared, and 2 times 2 is 4. So let's factor this difference of 2 perfect squares. Difference of 2 perfect squares has different signs. Okay? And then x times x is x squared, and 2 times 2 is 4. And then we're done. Make sure you have your GCF, the 3x, in the front there. Yeah, and so we had to factor 2 times. The first time we pulled out a GCF, then we factored our difference of 2 perfect squares. Anytime you see the word completely, that usually means that you're going to factor multiple times. Okay, and it's really easy for students to miss the difference of 2 perfect squares. So again, the difference, subtraction, and then x times x, 2 times 2. Those are both perfect squares. Okay, so completely usually means factor twice. Not always, but if you ever see the word factor the polynomial completely, make sure you check to see if it's fully factored. So again, the first step, no matter what, is to check for a GCF. Okay, so 2, 12, and 18 have a GCF of 2. But we also have to check our variables. So I have 3y's, 2y's, and 1y, which means I can pull out 1y. So when we do that, here we're left with y squared. Okay. Negative 12 divided by 2 is negative 6, and we're left with 1y. And then 18 divided by 2 is 9, and we pulled out that 1y. And so now we want to factor what's left over. Okay, this is just a trinomial. So you guys already know how to factor a trinomial. You can just use guess and check. Okay, y times y is y squared. And then plus 9, and it has to add a negative 6. So that's going to be 3 and 3. 3 times 3 is 9. And we need to make it add to negative 6y. So we want negative 3y minus 3y to give us negative 6y. Now we did learn this yesterday. This is a perfect square trinomial. But like I said, you don't have to memorize the pattern. You don't even have to recognize that it's a perfect square trinomial, because you can just factor using the guess and check method. Now, your book might fully simplify it, and they might write y minus 3 quantity squared. I do not care which way you write it. I will accept either. Okay, but that also is an acceptable answer because y minus 3 times y minus 3, those are the same factors. Okay. All right, again, your first step, always check for a GCF. So my GCF here is just an m. I can only pull an m out of all three of those terms. So we're left with m squared minus 2m minus 8. And then you need to check what's left in the parentheses and see if you can factor that. Okay, the other key thing, just make sure you write your GCF on the outside. Don't forget to do that. So let's see. What times what gives me m squared? First times first is going to be m times m. And then what times what gives me negative 8? Well, it has to add to negative 2, so you can try, let's see, 4 and 2 or 8 and 1. Okay, I would try 4 and 2 first. So let's do 4 and 2. Because I multiplied to a negative 8, one's going to be negative and one's going to be positive, but we need it to add to a negative 2m. So we need negative 4m plus 2m, and that will give me outer is 2m, inner is negative 4m, so 2m minus 4m is negative 2m. And we're done. That's fully factored. Like I said, the one that students usually miss is the difference of two perfect squares. So that's an important one. And we're about to do another one here. So 50 and 2, so my GCF is 2, and then I can pull out 2 of those x's, so x squared. So 50 divided by 2 is 25. I had 4 x's, I pulled out 2, and now there's 2 left over. And then negative 2x squared divided by 2x squared is negative 1. Okay, don't forget to write that minus 1. Anything divided by itself is 1. And now, again, this is critical for you guys to realize that this is a difference of two perfect squares. Difference because it's a subtraction sign, and then this is a perfect square because 5x times 5x is 25x squared, and 1 times 1 is 1. So let's factor that. This is what we did yesterday in section 7.7. So we have 2x squared. Okay, remember, difference of two perfect squares has different signs, so plus and minus. And like we just said, 5x times 5x is going to give us 25x squared, and 1 times 1 will give us 1. And you can see outer plus inner is negative 5x plus 5x, which is 0. That's why there's no middle term. Those opposite signs make that middle term 0. And then you can see the positive 1 times the negative 1 is the minus 1 here. And that is fully factored. So again, the difference of two perfect squares is really what you want to keep your eyes out for. That's the one that students miss the most. All right, so I just put this at the top of your notes that it's there in case you need to see it again. And now we're solving a polynomial equation. So you'll notice it says solve because there's an equal sign, right? It's an equation with an equal sign. Remember, you don't ever want to add in an equal 0 if there's not one already there. We only solve equations when they give me an equation to solve. So again, going back to the 7374 quiz, some of you were trying to do this. You were trying to take all your terms and set them equal to 0. And I was like, wait, what? We don't ever set terms equal to 0. We only set factors equal to 0. So in order to set the factors equal to 0, we're going to have to factor it. Okay. What's the first step in factoring? It's always to pull out a GCF, always. So my GCF here is W. Okay, so let's pull a W out of every term. And we are left with W squared minus 8W plus 16 equals 0. Don't neglect the equal 0. And then we need to factor what's left. So Don't forget your GCF on the outside, the W. And now let's factor this trinomial. Again, by checking yes, this does happen to be a perfect square trinomial, but I told you guys yesterday you don't have to memorize the perfect square trinomial pattern. You can just factor this like you normally would. Okay, W squared, that's going to be W times W. 16, I would probably try 4 and 4 first. So let's go 4 and 4. We need it to add to a negative 8W, so we want negative 4W minus 4W. And now, because we're solving, we need to set each factor equal to 0. This is your first factor, W. We need to take that W and set it equal to 0. Okay, and then we take the W minus 4 and set it equal to 0. Notice these are the same factor. You don't have to do it twice because you're going to get the same solution. So we get W equals 4. You don't have to tell me W equals 4 twice. Okay, otherwise you're just repeating yourself. So if it's the same factor, you just need to set that one factor equal to 0 once. Oops. So my solutions are W equals 0 and W equals 4. Now, we talked about in the lesson yesterday, we said we had some GCFs that were just numbers, right? Do I ever need to take the 2 and set it equal to 0? No, because 2 doesn't equal 0. That's a false statement. If it's just a number, you don't need to set it equal to 0. But if you have a variable, like the W, then we need to set the W equal to 0. All right, first step when you're factoring no matter what is to pull out a GCF. So my GCF here is x, which leaves us with x squared minus 25, all equal to 0. So you need to look at what's left over and see if you can factor that. We can, because that's a difference of two perfect squares. So start with your GCF, and then we know the difference of two perfect squares has different signs. Right, a plus and a minus. X times x gives us x squared. And 5 times 5 gives us 25. Okay, really it's the positive 5 times the negative 5, which gives us the negative 25. And if you check your outer plus inner, you get negative 5x plus 5x is 0. So there is no middle term. But we're solving, so remember this equals 0. So we need to take each factor and set it equal to 0. So we need to take the x and set it equal to 0, and that's one of my solutions. And then the x plus 5 factor, set that equal to 0, and the x minus 5 factor equal to 0. Notice those aren't the same, so you're going to get two different solutions. Subtract 5 from both sides, add 5 to both sides. Again, just a reminder, most students miss the difference in two perfect squares, so make sure you guys are keeping an eye out for that. Difference meaning subtraction. X times x is x squared, and 5 times 5 is 25. So that's difference in two perfect squares. All right, we have 4 terms here. So that means I'm going to factor this using factor by grouping. So let's group. It's already set equal to 0, which is exactly what we need. So group the first 2 terms together, group the last 2 terms together, and then notice that your third term is a negative, which means we're going to have to pull out a negative GCF for that group. Okay, so the first group has a GCF of x squared, and we're left with x plus 6. Again, anytime your third term is negative, you're going to pull out a negative GCF. So we're going to pull out a negative 4. And then I always like you guys to write it so that you don't forget to actually divide by a negative 4. So I want you to write divided by negative 4. So we're left with positive x, and then negative 24 divided by negative 4 is a positive 6. And that's still all equal to 0. So here's my GCF, x plus 6. Pull that out. And we're left with x squared minus 4. So again, this is the whole point of this section is to factor completely, which means you guys are factoring multiple times. Okay, previously you guys were pulling out the GCF and then you had a difference of two perfect squares, or you pulled out the GCF and then you factored a trinomial. In this case, we factored using factor by grouping, but what you'll notice is that we're left with a difference of two perfect squares. So we have to factor that. Again, this really right here is the step that a lot of students miss. Okay, so you got to make sure you're looking for those difference of two perfect squares. So to factor that, remember difference of two perfect squares has different signs. So we have a plus and a minus. Okay, x times x will give us x squared, and 2 times 2 will give us 4. And now it's fully factored, so now we can set each of those factors equal to 0. X plus 6 equals 0, so x equals negative 6. X plus 2 equals 0, subtract 2 from both sides, and x equals negative 2. X minus 2 equals 0, add 2 to both sides, and we get x equals 2. All right, A, B, and C all were already set equal to 0. That is not the case in D. So because we already have a positive leading coefficient of 2, let's just add the 36 over to the left side. Make sure it's in standard form. So our x cubed term comes first, then minus 18x squared, and then plus 36x. So that's one thing on the quiz I saw on the last problem. Some of you didn't have it in standard form, so you weren't able to factor it correctly. Standard form is important. Okay, once it's set equal to 0, you need to look for a GCF. So that's always going to be the first step now. So my GCF here is 2x. So look at your smallest number first. That's a 2, and they're all even, so I can pull out a 2. And then an x as well. So we're left with x squared minus 9x plus 18 equals 0. So we have, here I'm going to draw a line just to separate these two problems. All right, so we have our GCF 2x, and then we want to see, can we factor this remaining trinomial? And it looks like we can. So let's factor that. Okay, so we know x times x is x squared. So first times first is x times x. And then 18, I don't know, is it 6 and 3? Is it going to be 9 and 2? Well, we need it to add to negative 9. So that would be 6 and 3. Okay, but they need to add to a negative 9, which means we need negative 3x, sorry, negative 6x minus 3x. And that'll give us negative 9x. And now we need to set each factor equal to 0. This 2x factor has an x in it, so we need to take that and set it equal to 0. If it's just a number like 2, then 2 doesn't equal 0, so don't set 2 equal to 0 because that doesn't make sense. But if it has an x in it, then you need to set equal to 0. So x equals 0 for that factor. X minus 6 equals 0, we'll add 6 to both sides, and we get x equals 6. X minus 3 equals 0, we'll add 3 to both sides, and we get x equals 3. So if you plug in any one of those solutions into your polynomial, you will get a true statement. Those are 3 solutions. All right, we have one word problem, and then you guys have one star problem to try. You are building a birdhouse. Here's the birdhouse that will have a volume of 128 cubic inches. Ooh, volume. We have not talked about volume a ton. The birdhouse will have the dimensions shown. So you guys can see we have the height here, the width, and it looks like the length. Write a polynomial that represents the volume of the birdhouse. So volume is length times width times height. Volume's three-dimensional. So it doesn't matter which one you call which because you're multiplying them. So it doesn't matter what order you multiply them in. Let's just get our three dimensions and multiply them together. So we have the W plus 4 times the W times 4. Again, doesn't matter which one you call which because you're just multiplying them all together. Doesn't matter which order you multiply in. So let's actually multiply those. So when you multiply W times 4, that's 4W. And then let's distribute the 4W. So 4W times W is 4W squared, and 4W times 4 is 16W. So that's my volume. Volume equals 4W squared plus 16W. So they want to know what are the dimensions of the birdhouse. In order to find the dimensions, I have to find what W is. So we need to solve for W. Okay. Well, in order to solve for W, I have to know what V is. So if you go back up to the problem, they told us that the volume is 128 cubic inches. So I'm going to plug that in for V here, 128 for the volume, and that equals 4W squared plus 16W. That's what the volume equals. So now we almost have this trinomial that we can solve. We just need it to be set equal to 0. So let's subtract the 128 and put it on this side. So now we have 0 equals this trinomial. And we're going to factor this trinomial so that we can solve it, so that we can figure out what W is, so we can figure out the dimensions. Okay, so first step you want to ask yourself is, does this have a GCF? And it does. 4 goes into 16 and it goes into 128. So we're going to pull out a 4. So we're left with W squared plus 4W minus 32. And now we want to factor that remaining trinomial. So that's what we've been working on today, is factoring completely. So first times first is W squared. So W times W will give us W squared. Negative 32, well, we want it to multiply to negative 32 and add to 4. So that sounds like it will be 8 and 4. And we want positive 4. So we want positive 8W minus 4W to give us positive 4W. Outer plus inner. All right, and now to solve this, we set each factor equal to 0. Do we need to set this 4 equal to 0? No, because there's no variable there, and 4 does not equal 0, so that doesn't make sense, right? But W plus 8 equals 0. W equals negative 8. Probably not. W minus 4 equals 0. W equals 4. Okay, well, width cannot be negative, right? It's a length. It's a distance. It can't be negative. That doesn't make sense. And then we know that this is inches because they said that the volume was 128 cubic inches. So the width is 4 inches. So there's one of the dimensions. We have the other dimension. The length is 4 inches. We just found the width is 4 inches. And then to find the height, let's plug in 4 for W here. So, or sorry, we'll call that, it doesn't really matter, but we'll call that the height. 4 plus 4 means the height is 8 inches. So there's our three dimensions, 4 inches by 8 inches by 4 inches. And you guys can multiply those three numbers together, 4 times 8 times 4, and make sure you actually get 128 cubic inches for the volume, and you will. All right, last one, just because I'm not here to come around and check your star problem, let's just do this one together. Factor completely, that means you're going to have to factor at least twice, most likely. So the first step is that it needs to be equal to 0. Done. Second step, always got to check for a GCF. Okay, 3 goes into 18 and 24, so there's my GCF. The first term has 3 x's, the second one has 2 x's, and the third one has 1 x. So the greatest number that I can take out is 1. So we're left with x squared plus 6x plus 8 equals 0. And we're factoring completely, which means I probably can factor this remaining trinomial. So 3x times, let's factor this. We know x times x will give us x squared, so first times first. And then 8, I don't know, it could be 8 and 1 or 4 and 2, but we need it to add to 6x, so we know it's going to have to be 4 and 2. Okay, multiply to a positive 8, add to a positive 6, that means they both have to be positive. And then we need to set each factor equal to 0. This 3x is a factor, and it has an x in it, so that does need to be set equal to 0. If it was just a 3, then 3 doesn't equal 0, so that wouldn't make sense. But 3x can equal 0. Divide by 3, and 0 divided by 3 is 0. X plus 4 equals 0. Subtract 4 from both sides. And x plus 2 equals 0. Subtract 2 from both sides. And we're done. So it looks like right now the video is about 31 minutes. So you should have a little less than 20 minutes or so, probably about 15 minutes at this point to work on your homework. You can take out your phones and pull up your textbooks on your phone. It should be linked there under Google Classroom. However, I also printed out 10 copies of the book problems that the sub will have at the front of the classroom. So if you would rather just have a copy of that instead of pulling out your phone, then just ask the sub and the sub will give you a copy. There's only 10 though, so if some of you prefer working on your phone, then you can just pull out your phone and pull up the problems that way. Okay, please work on your homework for the next 15 minutes. Let's see, purple students are taking the 7778 quiz tomorrow. That's Thursday. Gold students, you're taking the 7778 quiz on Friday. For both classes, we're going to review before, but it would still be good to make sure you study and look over your notes and whatnot. So, all right, have a great rest of your day.